If those preliminary concepts are clear, we can now still start deep diving a little bit in how we can, let's say, distinguish or classify or interpret some production system according to some dimension. In particular, as we have introduced in the previous lecture, the first view that we are interested in is the managerial view. So how to distinguish production system typology according to a managerial perspective. First, in order to do that, we need to clarify which is the process of production system design. So in order to design a production system in a company, you first have to decide which is the product. So what your production system actually need to realize. And this means, of course, defining the object of your production system, which has as output what we will call the design of the bill of material. Once you know what you want to produce, you can then design the process. Design the process means first defining the approach that you want to use in managing this process, so how you want to satisfy the final demand of the customer, and then designing on a practical in practical term the action, so the job, the operation that you need to execute to realize the process. This means designing the production cycles and the production routing. Finally, when you have the production design and you have the process design, you can start with the production by start making the system working and try to understand if the real output that you are obtaining is aligned with what you have planned here on paper. Let's start with the product design. Of course, first of all, we have to define the different hierarchical level of our product. So, first of all, we need to decide and we need to define the unit of analysis for a production system. And same as we discussed when we talk about demand management, when we talk about product classification in a production system, we have different level of aggregation. We have what we call product type. So, like for example, Coca-Cola Light is a type of product that Coca-Cola realizes. So this is a product typology. Among the different class of product that Coca-Cola realizes, there is Coca-Cola Light. Then, within Coca-Cola Light, Coca-Cola has different families of Coca-Cola Light or different model of Coca-Cola Light. For example, they have Coca-Cola Light in can 0.33 liters, they have Coca-Cola Light in bottle of 1 liter, or they have Coca-Cola Light in PET 1.5 liter. This is a family of product. So Coca-Cola Light exist in the model of can 0.3 liter, 0.33 liters, bottle 1 liters, and PET 1.5 liters. Then, if we consider just one model, Coca-Cola Light can 0.33 liter, we can see that there are different item or SKU, stock keeping unit, that Coca-Cola used and which becomes unit in the supply chain. Because if we look at Coca-Cola Light realizing can 0.33 liter, we can see that we can have a 6 cans package to be transported to the final market. We can have a 4 cans package to be transported to the final market, or a 12 cans tray to be transported to the final market. So as you can see, we have different level of classification and different perspective on the product. Please remember that we are talking about supply chain management and supply chain. So don't confuse the product perspective that marketing has with the supply chain perspective on the product, that because this may be different. For marketing, this is just an example, just the type level could be relevant to design the marketing lever, so product, place, promotion, and so on. When instead for supply chain, it is important to highlight all the three levels because we need to know that there is one type of product which is Coca-Cola Light, which is distinguished by the other ones, but also that Coca-Cola Light can be realized in three different families, and probably these three different families require a different configuration of the production system, because if I realize a can in 0.32 liter, I need a configuration of the machineries which is different from realizing a bottle of 1 liter, which is different from realizing a PET of 1.5 liter. Then it is also relevant to keep the distinction in terms of SKU, because maybe it is not so different from a production perspective, but of course then distributing and realizing market distribution of 6 can package, 4 can package, or 12 can tray is different, so implies different supply chain procedure. So this is the view that we need to design in order that the product description is relevant from a supply chain management perspective. In particular, there is a tool, there is a representation which is very useful to do that, besides the distinction between type, family model, and SKU, which is named Bill of Material. The Bill of Material is no other than a hierarchical and structural representation of all the objects that compose a product. And this is a relevant element for the production system because it's telling the production system that it needs to realize this product, in this case cheeseburger, and to realize the cheeseburger it needs bread, cooked meat, salad, and mayonnaise. And in particular, cooked meat can have some variants. So meat can be molded meat or meat can be chopped meat. So even if we still don't know how to do that, we know that to arrive to the final configuration of the product, we have to use this material in this possible configuration. What you don't see here is that usually in the bill of material you have also what they are called usage coefficient. So to realize a cheeseburger, you need 2 slices of bread, in this case 2 hamburger, like 3 slices of salad, and 2 small spoons of mayonnaise. So this is, let's say, the explosion of the final product. I'm saying to the production system that I need to realize a cheeseburger, and to realize a cheeseburger I need bread, cooked meat, salad, and mayonnaise in this quantity and in this possible configuration or variants. You can see it's a different way to see the object of my production system, because in the previous case we have just distinguished in type, family, and SKU. Here I'm saying I'm exploring the content of this product. So actually how this product is made, and so which should be the characteristic of the production system in order to arrive to this final configuration. The bill of materials in companies has different type of representation. Can be vertical. This is a vertical representation like an organizational chart. Can be also horizontal, but the meaning is the same. Don't get confused by different notations. So here you have a hierarchical representation of the product that is vertical. So this is the final product. These are the first level components. These are the second level components, meaning the components that are needed to realize, or the materials that are needed to realize the first level component, and so on. But it's the same as here. Then, once you know which is the product that you need to realize in terms of which are the families, which are the type, which are the families, and which are the stock keeping unit that you have in your supply chain, And then once you know which are also, let's say, the content characteristic of each one, and again, the bill of material unit of analysis depends on how you want to deep dive. So you can do a bill of material for each SKU, you can do a bill of material of each family of product, or you can do a bill of material of each model of product. It depends, or sorry, type of product. It depends on which are your needs. Independently from that, once you have clear in mind which is the type of product you need to realize, which are the different configuration, and which is the content of that product, a critical decision that you need to take is how are you going to satisfy the market demand. So how you want to manage the delivery lead time. So again, think about the fact that the production process is characterized by a delivery lead time, so the time that encompass since the moment in which the customer requests the product and the moment in which the product is ready to be delivered to the customer. Production process can be structured in order to manage differently this delivery lead time. And now we're going to see which are the different systems that can be configured according to the way in which a production system can manage the delivery lead time. Let's see this representation. This is the date of the order, okay? So this is the date, the time in which the customer puts the order, and that's the due date. So the customer asks the product here and would like the product to be delivered on this date. So this is the customer desired lead time, okay? So that's the time that the customer allow you to realize the product. The first case can be the case in which when the customer put the order, you haven't done anything to arrive to the final configuration of the product. So when the customer puts the order, you still have to engineering the product. So practically speaking, realizing the bill of material and understanding the characteristic of the production system that you need to realize that product. That means engineering. So you have to do engineering, you have to do purchasing, because once you have known which are the characteristics of the product and which are the characteristics of the production system, you know also what you have to buy to realize that product, like for example from the bill of material. Then you have to manufacturing, so to realize practically the product, and if you have also assembly, in assembly phase, you have also to assembly. So a first case is the one in which the customer puts the date of order here, and you do everything from scratch. So according to the order, you tailor, engineer, and design the product. Then you make specific purchases, you start manufacturing, and then you conclude assembly. These systems are called engineering to order. So these production systems are systems that works after having received customer order, but also working on the engineering. So when they receive the order, the production system has not been configured yet, and neither the product is. So we need still to engineering according to the characteristic of the customers. This is typical of like the aerospace industry. When government ask, let's say, aerospace and defense company to realize a new helicopter, nothing is ready. I mean, when the customer gives the contract to the company starts realizing the design and the engineering of the helicopter, and then understand which are the suitable material to build this helicopter, and then start manufacturing and assembling the product. Engineering to order. Engineering of the product start after having received the order. Why? This is possible because the customer puts the date of order here, and you have the due date, which is here. So you have time to do engineering, purchasing, manufacturing, and assembly. Second case, the date of the order is no more here, but is here. And the due date is still fixed. So there are industries in which the customer desired lead time is not so long, but is like this. Okay? So in this case, it means that you can't wait to do the engineering when the date of the order will arrive, because when the date of the order will arrive, if you still have to do the engineering, you will be late on the scheduled due date. So in this case, when the customer order arrives, you still have in mind which is the configuration of the product and the configuration of the production system, because the engineering phase needs to be made in advance, so before the date of the order put by the customer. While instead, you can wait to purchase specific materials, manufacturing, and assembly. These systems are called purchase to order. Purchase to order are contexts in which you can wait to purchase materials, so to have material on stock and to manufacture product and to assemble product until the date in which the customer will give you the order. However, you still have to have in mind which is the characteristic of the product that you need to realize and which will be the structure of the production system that you need to put in place to realize to the product, the final product. An example of this is, let's say, keeping in the example of project-based industries is shipbuilding. Big ship constructor, like for example, ship for touristic ship, don't engineer from scratch ship model. They already have a predefined ship model with a way to assembly and manufacture and purchasing material for them that are on shelf. And whenever a company or also government asks for a new ship, they start from actual design that they have. They maybe readapt something, but the model of the product, the bill of material is already present. They start with the project by purchasing materials and then manufacturing and then assembly. Purchase to order. Third case, there are industries in which the date of the order is not here, is here. Here means that, again, not only you can wait to engineering the product until the date of the order, but you can even purchasing after the date of the order, because otherwise you will be late. So in this case, when the order will arrive, you should have already engineered the product and the production system, so you should have an idea of product classification, the bill of material, and you also have to have materials which are already in the inventory. So material, parts, sub-assembly which are needed to realize the product should already be in the inventory. So in fact, as you see here, the inventory is real. You should already have inventory of raw materials, component, and sub-assembly to realize the final product. While instead, actual production and actual assembly should be made after the order, so you can start keeping your production system active after you have received the order. This system are named make to order. Because they can wait to start making stuff after the customer order arrives. However, they already have to have in mind everything that is needed to realize the product, and they already have to have in inventory whenever that is needed to practically realize this product. Example of this is manufacturing is whenever you ask to a company a new machinery. So there are industrial companies that realize capital equipment for other companies. They usually do that in make to order. So they know models that they propose to the market. They already have different type of production system in place to realize that, and they have materials already on stock. Of course, then specific purchases can be made, but generally speaking, they already have materials on stock. Another company puts an order for a machinery like a bending machine, like a cutting machine to be realized. This machinery is start being produced after the order, but everything that is needed to realize this machine is already on stock. Make to order. The production system start working after having received an order from the final customer, having all the materials, components, and subassembly to realize the product, and having in mind already the design of the product and the configuration of the production system. Fourth case, there are industries in which not only the due date, the date of the order comes after engineering and purchasing, but comes so late that you still have to be realized, so manufacture the product. So the first case is in which the date of the order is here, and not only you should have designed the product, purchasing material, but you should have also produced the main, let's say, components to realize the final product. What you can wait to do, and so you should have work in process of components, what you have to wait to do is the assembly part, assembly to order. So the product components are here, are waiting to be assembled, and you can wait to assemble them until customer order arrives. Assembly to order. Typical example is the automotive. Cars are usually present in car manufacturer inventory in their different parts, like brake, steering, engine, doors, seats, and so on. When the orders from the distributor comes, they start assembling the final product. Assembly to order. Fiat, Chrysler, Chevrolet don't have already assembled cars in their plant. They start assembling them when they receive orders from the distributor. Assembly to order. Last, let's say the worst case according to what we have seen, there are industries in which you cannot do anything after having received the customer order. So there are industries in which the customer demands something, and this something should already be made, should already be available on stock. So they ask that being on stock, so being already present in the grocery store or in the retail store or whatever. These are make to stock system. So all these activities, all the activities which are surrounding the production system, engineering, purchasing, manufacturing, and assembly, need to be executed in advance. So they are forecast based. They are made upon forecasting. Think about like clothing industry. You go, you look for a shirt, and you don't want, as far as you don't ask for tailor-made like suits or shirt. If you go to a clothing shop, you want the product to be present in the shop. So you don't express your need, and after some times you will receive that. You want this to be present on shelf, make to stock. When you go looking for a phone, you want to find a phone in the shop, in the store. So you won't just say, okay, I want this phone like this, and you will wait this to be delivered. No, you want it on the shop. So it means that on the store. So it means that these industries are in this situation. So the date of the order comes after that, all these activities from a time perspective need to be executed. Make to stock. So you realize in advance, you make your production system working in advance in order to have product on stock. These are different ways to manage delivery lead time. In this case, the delivery lead time is all seen by the customer because customer ask and then wait all the phases to have the product in his hands. One extreme. The other is the delivery time is not seen by the customer because the customer asks something and in time zero would like this product to be in his hands. So the delivery time shouldn't exist. Everything should be made on a forecast base. When instead in this case, the delivery time can be or purchasing, manufacturing and assembly, or manufacturing and assembly, or just assembly. This realized different production system. So make to stocks, assembly to order, make to order, purchase to order, and engineering to order are different approaches to realize a production system. Of course, a production system that work on engineering to order or on make to stock are very different. And we already talked about this fact when we also introduce the score model. Not by chance, the score model distinguish the structure of the processes according to their production approach. Now everything should be clear, and process and pieces can make more sense. Then, once you know which type of approach you want to use to manage the delivery time, you can then design what is called production cycle and routing. Production cycle and routing is no other than the list of the operation that needs to be performed to transform raw materials into a finished product into the production system. You see here, this should be clear by this table. These are the phases, so phase 1 or 10, phase 2, 20, 30, 40, 50, and they comes in chronological order. So the first phase is cross-cutting, the second is lathe, the third one is trimming, then you have grinding, and to do cross-cutting, you need the cross-cutting machine I11 that needs to work 30 seconds and needs a setup time of 4 minutes to be configured to produce a new product. Okay, so this production process starts with phase 10, doing cross-cutting with the machine I11 for 30 seconds, setup time 4 minutes. Then goes to lathe phase, which use lathe A21. It uses 2.5 minutes, and he uses tools, so he needs a tool to work, tool XYZ, and he needs setup time of 1 minute to be configured, and so on. This is named production cycle. So it's saying to you which is the path that your product is doing every time that is entering a production system. And that's another parameter that you need to define when you configure a production system. Let's conclude this part by putting together some configuration dimensions that can be used to classify production system from a managerial perspective according to what we have seen until now. So the first configuration dimension is the way that you use to manage the delivery lead time, from engineering to order to make to stock. Example, make to stock, again, clothing. Make to order or purchase to order, according to a different context, can be like shipbuilding industry. Of course, purchase to order for bigger job, if instead like it's just a personal boat, it can be just make to order. They already have materials on stock. While engineer to order are all the aerospace and defense or train industry. You can cross this. So on one side you say, okay, we manage the delivery time in this way, make to stock, assembly to order, make to order, purchase to order, and engineer to order. And you can then also match this with the type of product that you realize, so the type of production that you realize. And in this case, you can distinguish between discrete production and continuous production. Discrete production is everything that is produced through a production system that realizes units. Example, this is a tractor. Okay, tractor, like automotive, like smartphone, is realized one by one. So the production system works one by one, discrete production. Okay, it relies one car, then the other one phone, then the other one tractor, then the other one, which is different from continuous production. Like for example, paper production does not work in unit. Is a system that works on a continuous basis and realize quantity of paper that then is separated in further phases, but is a continuous production. Similar of this is also the semiconductors industry. Let's say you have seen the video chips. Chips is a continuous production. You see that the process is a continuous flow. It is not discrete. It doesn't realize unit. It relies on a continuous basis the product. So there's a second way to classify production systems. On one side, the way in which we manage the delivery lead time. On the other axis, the way we manage production. So it is a discrete production or a continuous production, which is of course typical of the characteristic of the product. A third axis is again another type of dimension, which is product related. So if the product is simple or complex. In particular, when the product is complex, we usually refer to as part production, and when the product is simple, we refer to as process production. So we have one axis which is purely managerial, so the way in which we decide to manage the delivery time, and the other two which instead try to characterize a little better the unit of analysis of the production system. So if it is a discrete or continuous production, or if it is a simple or complex product. So two dimensions to classify the products. Example, shoes. Shoes are made to stock, because when you go to a shop, to a store, you want the shoes to be there. Men's shoes, these are classic men's shoes. They are realized on a discrete production. So two pairs, one pair, second pair, and so on. They are manufactured and then assembled, and they are complex. So again, should be in 3 dimensions, but they are a complex product because they are made of different parts, they need different treatment and so on. So this is a part production manufacturing for complex product. This is water. Water is also made on make to stock. So they relies on a forecast base like San Pellegrino case. It is relies on a continuous production. If you see a production process of water, you see that it is like chips. Okay, so water's flow on the production process is quality controlled, is then put in bottle, but it is a continuous process. And of course, it is not a complex product. Of course, this should be in perspective, but of course, water is a simple product. So in this case, for shoes, you will have a production system which is make to stock, discrete production, complex product characterized, while for water, you have a make to stock, continuous production, simple product, production system characterized.